In one of the most desolate places on Earth, there are pieces of glass, not bottles, not volcanic rock, not human artifacts, glass. Thousands upon thousands of fragments scattered across the Sahara Desert like shattered gemstones from another world. Some are translucent yellow, some are almost green, some so pure they rival laboratory glass. And for nearly a century, scientists have been trying to answer one question. How do you melt an entire desert without leaving behind the thing that melted it? Near the border of Egypt and Libya lies a region known as the Great Sand Sea, an ocean of dunes stretching for hundreds of kilometers. And hidden among those dunes is one of geology's strangest material, Libyan Desert Glass. Scientists estimate these fragments formed around 29 million years ago. But this material presents an immediate problem because deserts are not supposed to produce glass, at least not like this. Most natural glass on Earth forms in volcanoes. Rock melts, cools rapidly, and solidifies before crystals can form. That's how you get obsidian. But there are no volcanoes here, no ancient lava flows, no volcanic mountain chains, nothing. And that means something else melted this desert, something powerful, enough to briefly raise the temperature of ordinary sand up to 1600 degrees Celsius, hot enough to melt quartz itself. Now here's where things become genuinely strange. This glass is almost unbelievably pure, nearly 98% silica, far purer than most naturally occurring glass on Earth, which tells scientists something critical. The glass formed from the desert sand itself. The Sahara melted right where it stood. So, what could create this much glass? Well, lightning can melt sand. When lightning strikes the ground, temperature briefly becomes hotter than the surface of the sun. It creates structures called fulgurites. But fulgurites are small, localized, usually tubular. Libyan desert glass covers thousands of square kilometers. So, lightning is out. Volcanoes? Also out. There's simply no volcanic system here capable of producing this material. So scientists turn toward the sky because Earth exists inside a cosmic shooting gallery. Every day, our planet is struck by material from space. Most of it burns harmlessly in atmosphere, but occasionally something bigger arrives. Something catastrophic. As an asteroid plunges into Earth's atmosphere, it compresses the air in front of it. That compressed air hits dramatically, and if the object traveling fast enough, the atmosphere itself becomes a furnace. Scientists began wondering, could an enormous asteroid have exploded in the air above the Sahara without ever reaching the ground? This is called an airburst. And we know airbursts are real. In 1908, something exploded over Siberia. The blast flattened nearly 80 million trees across more than 2,000 square kilometers. No impact crater was found. Then in 2013, another asteroid exploded over Chelyabinsk, Russia. The shock waves shattered windows across the city and injured more than 1,000 of people, again without creating a crater. So the airburst theory seemed promising. A massive explosion in the atmosphere, possibly enough to flash melt desert sand into glass. And for years, many scientists believed this was the answer, until the rocks themselves revealed the problem. Inside the glass are tiny crystals called zircon. Zircons are remarkable minerals. They are extraordinarily durable. Tiny time capsules capable of surviving geological violence for billions of years. But under extreme pressure, zircon can transform. Its atoms rearrange into entirely different structure. A rare mineral called reidite. And reidite changes everything because reidite forms only under immense shock pressures, the kind generated during hypervelocity impact. To create reidite, rock must experience pressures so extreme that its atomic structure physically collapses and reorganizes, which means the desert glass was not simply heated, it was shocked. And suddenly the airburst explanation no longer seemed complete. because while air bursts generate heat, they generally do not create the enormous ground pressures required to form reidite. So now scientists face a new contradiction. The glass field looked like an airburst, but the mineral looked like an impact. And somewhere beneath the Sahara, the missing evidence may still be buried. If a cosmic impact created this glass, where is the crater? That question remains unanswered. No known crater nearby is large enough to explain the scale of the glass field. But deserts are deceptive landscapes. Wind erases, sand buries. Geological time destroys evidence. A crater formed 29 million years ago may no longer resemble a crater at all. It may lie hidden beneath dunes or eroded beyond recognition. And this is one of the most important lessons in planetary sciences. Thousands of years after this cosmic event, humans found the glass and they transformed it into something sacred. One of the most famous artifacts connected to Libyan Desert Glass was discovered inside the tomb of Tutankhamun. At the center of ceremonial scarab necklace sits a polished yellow gemstone carved from the ancient desert glass. Think about that for a moment. Ancient Egyptian craftsmen held in their hands the aftermath of a cosmic collision, not knowing its origin, not knowing it came from an event older than humanity itself. Libyan Desert Glass is not merely a geological curiosity. For nearly 29 million years, the Sahara kept this story hidden, not in a crater, but scattered quietly across the sand. And even now, desert has not revealed everything.